Here we're going to look at what we call the first derivative test. Okay, so the first derivative test says if your derivative is 0 and f of x changes from positive to negative, then f of x has a maximum point. Okay, so here we're saying if the derivative changes from positive to negative, then we have a maximum point. The second part says if your derivative is 0 at a and f of x changes from negative to positive, then you have a minimum point. Okay, so I'll tell you that for me, just memorizing these theorems, this test never worked for me. But if you think about the picture, and I'm normally not a picture person, but if you think about the picture, then I think it helps. So what does, let's look at this first part. It says if f of x changes from positive to negative. Now, when f prime of x is positive, our function is increasing, right? When it's negative, we're decreasing. Well, all this is saying is if you go from increasing and change to decreasing, you're going to get your local maximum point. That could also be a global max, depending on the situation. Okay, and what the second part says is if it changes from negative, so decreasing to increasing, then we get a minimum point. So I really think looking at the, kind of thinking about what happened if you go from increasing to decreasing or decreasing to increasing, which one you get. Okay, so this says in the following problems, find the intervals where the function is increasing or decreasing, and then identify the function's extreme value. So we already did half of what we're doing here in the last one, but we're now going to actually talk about the minimum or maximum values. So our first function here, we have f of x equals negative x squared minus 3x plus 3. So we're going to take our derivative, which will be negative 2x minus 3. And we know this is a parabola. You probably also know that's facing down, so we'll have a maximum, but we'll see that. So we'll take negative 2x minus 3, set it equal to 0. We'll get negative 2x equals 3, which means x equals negative 3 halves. So we're going to make our sign diagram for f prime. We'll put negative 3 halves on here. So we could pick, so I put the f prime here to remind you that you're plugging these test values into your derivative. So if I pick something greater like 0, I get negative 3, so we'll put negative. And if I pick something like negative 2, I'm going to get 4 minus 3, which is 1, so this is positive. So what this tells us so far is that f of x is increasing from negative infinity to negative 3 halves and decreasing from negative 3 halves to infinity. Now, so if you think about the picture, we go from increasing to decreasing. So we're going to have f of x has a maximum of, and right now I'm going to leave that blank for just a second, at x equals negative 3 halves. Now you won't have to put this line in there when you write it out, but I'm putting that there because we need to find what the maximum value is. Now to get the actual maximum value, we're going to plug our negative 3 halves into our original. So we want f of negative 3 halves. So we're going to do negative 3 halves squared minus 3 times negative 3 halves plus 3. Okay, so we get 5.25, which as a fraction is 21 over 4. Okay, so just by taking that first derivative and looking at it, we found out quite a bit about that parabola. We found where it's increasing, where it's decreasing, and what the maximum is. Okay, here we have a quartic function, something of degree 4. Now, to help us out, this should actually be, I have a little bit of a typo here. this should be a squared, not times 2. Okay, so if we take the derivative, we're going to have 4x cubed minus 16x. And we want to know where is that equal to 0. First thing I can do is pull out a 4x, which will give me x squared minus 4. And then we know x squared minus 4 factors as x minus 2 and x plus 2. So we've got critical points at x equals 0, x equals 2, and x equals negative 2. So I'm going to make my first derivative sign chart, so I'm going to put negative 2, 0, and 2. Since we're going to have so many values to test here, we're going to have our calculator help us. There's no good place to put it, but so in my y equals, I'm going to put the first derivative, since we're going to fill out the first derivative chart. So 4x cubed minus 16x. I'm going to get over here. Okay, so we're going to test something less than negative 2, so we can do negative 3, and that's negative. Now we want to do something between negative 2 and 0, so I'll do negative 1. That's positive. Between 0 and 2, well, I could keep this 1.5 here, it's going to be negative. And greater than 2, I could do 3, and it's positive. Okay, so already this gives us a lot of information. We know that f of x is increasing from negative 2 to 0 and from 2 to infinity. Or we could just say we're increasing on the interval from negative 2 to 0 union 2 to infinity. And it's decreasing from negative infinity to negative 2 and from 0 to 2. Okay, now, this is how I like to think about it. So we're decreasing, then increasing, then decreasing, then increasing. So that means when we go from decreasing to increasing, we're going to have a minimum of, and I'll leave a blank for a minute because we'll fill it in at x equals negative 2. Then we're going to have a maximum of something at x equals 0. And then we'll have a minimum of something at x equals 2. Now remember, to get our max and our min values, we're going to go back to our original function, our f of x. These are actually the y values on the graph. So we're going to do x to the 4th minus 8x squared plus 16. Okay, and now we can go to our table. And so we want to know at negative 2 what our minimum is, 0. And we want to know at 0, we have a maximum, and that's going to be of 16, that's going to be 16, and at 2 we get 0 again, so we have a minimum of 0 at negative 2, a maximum of 16 at x equals 0, and a minimum of 0 at x equals 2. And if we look at the graph, okay, we see that our minimums are actually global or absolute minimums. It's going off to infinity on both sides, so our maximum is a local max. Okay, we've got one more that we're going to look at here. So we're going to look at 15x cubed minus x to the fifth. So the derivative, 45x squared minus 5x to the fourth. If we set that equal to 0, we can pull out a 5x squared, which is going to give us 9 minus x squared equals 0. And this will factor as 3 minus x and 3 plus x. So we get from the x squared, we get x equals 0. Then we get x equals 3 and x equals negative 3. So those are where our critical values are. So I'm going to make our first derivative sign chart. Okay, so let's pull out our calculator. We're going to put our first derivative in here, so that's 5x squared minus 5x to the fourth. Okay, so I'm going to test something less than negative 3. So I'll do negative 4, that's negative. Then I'll do something between negative 3 and 0, so I'll do negative 1. Then 2 works, and then I need something bigger than 3, so 4. Okay, so look, here we're going to have negative, positive, positive, negative. So, at 0, our derivative is 0, so we're actually very quickly not increasing or decreasing, and we'll see what happens here later. So when we say we're increasing, we're going to say f of x is increasing from negative 3 to 0, and then from 0 to 3, and we're decreasing from negative infinity to negative 3, and from 3 to infinity. Now, when we talk about our mins, our maxes, so we're decreasing, then increasing, then we kind of slow down, but then we keep increasing, and then we're decreasing. So at 0, we don't have a max or a min. We have a minimum, and we'll look up what those values are in just a minute, at x equals negative 3, and we have a maximum at x equals 3. Now remember, to get the min and the max, we're going to plug in our f of x, our original function. We have 15x cubed minus x to the fifth. So I want negative 3 and 3. So we've got a minimum of negative 162 and a maximum of 162.